Imagine holding a time machine in your hands, not a device built from wires and gears, but something that has been inside you from the moment you were born. Something so small you can't see it, yet so powerful it can tell a story stretching back hundreds of thousands of years. That time machine is your DNA. It's not just the code that makes you, you. It's a historical record, an unbroken chain of information passed down through countless generations. Every success, every survival, every human who managed to live long enough to have children is written into that code. And if we know how to read it, DNA becomes the greatest storyteller in human history. Now, fossils have always been the star of human evolution stories. A bone in the ground, a skull hidden in stone. They feel tangible. But fossils are snapshots. They tell us shape, maybe age, maybe what someone ate if we're lucky. DNA is the full movie reel. It tells us who our ancestors were, where they lived, and how their descendants spread across the world. It even tells us which branches of the human family tree survived and which were lost forever. So how do we read this story? We start with the simple fact that DNA changes over time. Not a lot, not in big ways, but slowly, predictably. A tiny mutation here, a tiny tweak there, passed down from parent to child. And once it appears, it becomes a permanent bookmark in history. That mutation doesn't just exist in one person. It gets passed to all their descendants. If you carry it today, that means you share a common ancestor with every other person who has it. Scientists call these family lines haplogroups. Each one marks a chapter in the human journey. But here's the secret that makes this all possible. Most of your DNA gets shuffled every generation. You're half your mom, half your dad, mixed together. That makes it impossible to trace one straight line, except for two places in your genome that almost never mix: mitochondrial DNA and the Y-chromosome. Mitochondrial DNA is special because you get it from your mother, and only your mother. She got it from her mother, who got it from hers, all the way back through time. Fathers don't pass it on at all. That gives us an unbroken maternal line that leads to one woman, somewhere in Africa, more than 150,000 years ago. Scientists call her Mitochondrial Eve. Every single person alive today carries a copy of her mitochondrial DNA. Not the exact same. Mutations have happened since, but the root of that tree is hers. And then there's the Y chromosome. Men get one from their fathers, and only their fathers. Women don't have it at all. That means all men alive today can trace a straight line back to one ancient man. He lived maybe 200 or even 300,000 years ago, also in Africa. We call him Y-Chromosomal Adam. He wasn't Eve's husband. They likely never even lived at the same time. But every father's son today belongs to his branch of the tree. Think about that for a second. Every war, every migration, every culture, strip it all away, and at the very base of the tree, we all converge on two people. Not the first humans, but the ones whose lines never broke. All the others? Gone. Extinct. Their branches fell off the tree long ago. How do we know when these ancestors lived? We use the mutation clock. Every few thousand years, a predictable change shows up in the DNA. When scientists compare these changes across people from all over the world, they can estimate when those changes happened. It's like reading the rings of a tree, but in your blood. Combine that with archaeology and climate data, and suddenly the story comes alive. Who these people were when they walked the earth, what the world looked like through their eyes. And that world began in Africa. Every genetic breadcrumb leads back there. The oldest haplogroups, the deepest roots, all start on that continent. Our species was born there, somewhere around 200,000 years ago. Those early humans faced a world that was dangerous, unpredictable, and often brutal. And yet, They survived long enough for some of their descendants to leave Africa tens of thousands of years later. But here's what most people don't realize. When they left, they carried only a tiny fraction of the genetic diversity still in Africa. That's why African populations today hold the oldest, richest DNA on Earth. They're the closest living link to humanity's origin. So where does that leave us? With a new understanding of who we are. DNA reminds us that the divisions we obsess over, race, borders, nations, are new, recent. Beneath the surface, we're branches from the same tree, leaves on the same vine. And now, for the first time in history, we can trace that tree all the way to its roots. Because here's the most incredible part. This isn't theory. It's not myth. It's measurable. You can take a cotton swab, send it to a lab, and in a few weeks, you'll know which branch you're on. Are you carrying the oldest lineage on Earth? Are you a child of the first mothers who stayed in Africa, or of the wanderers who left to populate the world? Every answer is hiding in those twisting ladders of A's, T's, C's, and G's. We're going to dig deep into those answers. We're going to meet Mitochondrial Eve, not a character from a holy book, but the real woman whose DNA you carry right now. Who she was, where she lived, and how her legacy shaped the entire human story. After that, we'll meet Adam. Then, we'll follow their descendants step by step, mutation by mutation, as they spread across the globe. The story of our species is written inside you, and if you think you know it, you're about to be surprised. So here's my question for you. Do you know your haplogroup? If you've tested your DNA, drop it in the comments. And if you haven't, stick around. By the end of this series, you'll know exactly where you fit in the oldest family tree in the world.